compounds, proportions and rate of work, direct and inverse proportions. We looked at inverse and direct proportions in Form 1, where we dealt with the two variables, that is distance traveled and time taken. For example, if a car takes 3 hours to cover a distance of 200 kilometers, how long will it take to cover 280 kilometers? Solution: distance traveled is proportional to time taken. Using the ratio method, distance increases in ratio 280 to 200. Time will increase in the same ratio. Therefore, 280 over 200 times 3 hours gives us 4 and 1 over 5 hours. Using the unitary method, here we find out time taken to cover 1 kilometer. If 200 kilometers take 3 hours, 1 kilometer will take 3 over 200 hours. 280 kilometers will take 3 over 200 times 280, which is 4.5 hours. Another example: 5 men finish a task in 12 hours. How long will it take 3 men to finish the same task? Using the ratio method, the number of men decrease in the ratio 5 to 3. Therefore, time taken increase in the ratio 3 to 5. 3 men will take 5 over 3 times 12, which is 20 hours. Unitary method: 5 men take 12 hours, which means 1 man takes 5 times 12, which is 60 hours, and therefore 3 men take 60 over 3, which is 20 hours. Proportional parts: if 3 people A, B and C share 12,000 shillings in the ratio 3 to 4 to 5, how much will each get? A to B to C is 3 to 4 to 5. A gets 3 over 12 times 12,000, which is 3,000. B will get 4 over 12 of 12,000, which is 4,000. And C will get 5 over 12 of 12,000, which is 5,000. In general, when x is divided in the ratio m to n, the proportional parts are m over m plus n times x and n over m plus n times x. Compound proportions: this is where a variable depends on more than one variable. For example, 5 people staying in a guest house for 4 days pay Kenya shillings 20,000. How much would 10 people staying in the same guest house for 3 days pay, assuming the charges per day remain the same? In the solutions, 3 variables are number of people, days spent and amount paid. If the number of people increase, the amount increase and vice versa. If days spent increase, the amount paid increases and vice versa. Using the ratio method, number of people increase in the ratio 5 to 10, and so does the amount paid. Days spent decrease in the ratio 4 to 3, and so does the amount paid. We have 10 over 5 times 3 over 4 times 20,000, which is 30,000 shillings. You must be able to determine how a change in each variable affects the others, that is directly or inversely. Using the unitary method, 5 people staying for 4 days pay 20,000. One person staying for 4 days will pay 20,000 over 5. One person staying for 1 day pays 4,000 over 4, which is 1,000. 10 people staying for 1 day pay 1,000 times 10. 10 people staying for 3 days pay 10,000 times 3, which gives us 30,000. Another example, 8 people take 5 days to dig a trench 30 meters long. What length would 12 workers dig in 3 days? There are 3 variables, that is number of workers, number of days, and the length of the trench. If the number of workers increase, the number of days taken decrease. However, if the workers increase, the length of the trench increase. Using the ratio method, workers increase in the ratio 8 to 12 or 12 over 8. Days decrease in the ratio 5 to 3 or 3 over 5. What is the effect on the length of the trench? We shall have 12 over 8 times 3 over 5 times 30, which gives us 27 meters. Attempt the above question using the unitary method. We move to rate of work. This is the amount of done per unit time. The reasoning is just as in the previous case, that is, determining the relationship between variables, direct or inversely proportional. For example, 9 men working for 8 hours per day finish a job in 20 days. If 15 men were to finish the same job for 10 days, how many hours must they work in a day? In our solution, there are 3 variables: number of men, hours per day, and the number of days. Men increase at the ratio of 9 to 15 or 15 over 9. Days decrease in the ratio 20 to 10 or 10 over 20. What's the effect on hours per day? We shall have 15 over 9 times 10 over 20 times 8, which gives us 9 and 3 over 5 hours per day. Another example, pipes A, B, and C fill a tank in 3 and 4 hours respectively. If a third pipe C can empty the tank in 5 hours, A, how long will A and B take to fill the tank with C closed? How long will it take the tank to be full if all the pipes were opened? In our solution, in 1 hour, pipe A fills a third and pipe B fills a quarter. Therefore, in 1 hour, the tank will be 1 over 3 plus 1 over 4, which is 7 over 12 full. In 1 hour, the tank is 7 over 12 full. What about 1 full? Given by 1 hour times 1 divided by 7 over 12, which is 1 and 3 over 7 hours. If all the tanks are open, after 1 hour, A and B fill 7 over 12, and C will empty a fifth in 1 hour. So, after 1 hour, we shall have 7 over 12 minus 1 over 5, which is 23 over 60 parts of the tank will be full. It will therefore take 12 and 14 over 23 hours to fill the tank. Finally, we look at mixtures. When two or more materials are added together, the resulting mixture has a quality and value different from either of the ingredients. For example, 2 grades of sugar cost 25 and 30 shillings per kilogram. In what ratio should they be mixed to give a mixture worth 28 per kilogram? In our solution, let the grades be A and B, costing 25 and 30 respectively. If m kilograms of A are mixed with 1 kilogram of B, total cost will be Kenya shillings 25m plus 30. Mass of the mixture will be m plus 1 kilogram. Total cost will be 28 times m plus 1. Total cost of grades separately before mixing is equal to the total cost of the mixture, that is 25m plus 30 should be equal to 28 into m plus 1, and solving that, m is 2/3. The ratio of the mixture is therefore 2/3 to 1, which is 2 to 3 in the ratio A to B. Finally, ballast, sand and cement are mixed in the ratio 3 to 2 to 1. If 5 tons of ballast cost 6,000, 3 tons of sand cost shillings 3,000, and 3 tons of cement cost 21,000, find the cost of 2 tons of the mixture. In the solution, 6 tons of the mixture has 3 tons of ballast, 2 tons of sand and 1 ton of cement. If 5 tons of ballast is equal to 6,000, 3 tons will be 3/5 times 6,000, which is 3,600. If 3 tons of sand cost 3,000, 2 tons will be 2,000. If 3 tons of cement costs 21,000, 1 ton will cost 7,000. Total cost of the mixture is 3,600 plus 2,000 plus 7,000, giving us 12,600. 6 tons of the mixture would cost 12,600. 2 tons will therefore cost 4,200 shillings.
This is my own and my soul. This is my own. I have a goal. I believe I will succeed in my goal. This is my own.
Islington College.